let's learn about the area formulas. I'm going to give you some tips on finding the area for all the shapes and how to use the MCAS formula sheet. Let's get ready. You're going to need notes and pencil and a calculator. And this is just part of the MCAS formula sheet that we're going to be looking at today. So you can see we have the area formulas for a square is S squared. For a rectangle is length times width, that's L times W. Parallelogram, B times H is base times height. Triangle is half of a rectangle, so it's 1/2 base times height. Trapezoid is 1/2 times the height times the bases add together. And this is the first time we're seeing a circle this year, so we've got circle equals pi r squared. Here's our circular formulas. Just remember that pi is about 3.14. The circumference could be 2 pi r or pi d. So in our circle, if we go to the middle, half of the way distance across would be the radius, and then the full distance across is the diameter. And then we have our area formula. So some things to note about the formulas is notice how these are all capital A's, and then all of the side on the right are small lowercase letters. The capital letters means that something has been calculated already. The lowercase angles means that it's just a straight measure, and then you use those measures to make the area formulas. A lot of the formulas are going to require the height, and when we talk about height, we're looking at the perpendicular height. So in this parallelogram, we have our height here, which is perpendicular. It's not this. That's a slanted piece that's not perpendicular. In our triangle, we have our perpendicular height. In our trapezoid, we have our perpendicular height. Also a reminder with area, we're doing something times something. In this case, we're doing inches times inches. So this one would be 77 inches squared. So let's try some. So here we have the area of a rectangle. Find the area of a rectangle with a diagonal of 20 inches and a side of 12 inches. The formula is area equals length times width. The first thing I'm going to start to do is draw a labeled diagram. And I know that my diagonal is 20 and a side is 12. And it doesn't matter which side you make, 12. But I need length and width. So I'm going to call this my width, but I don't know my length. So I know that this is a right angle, so we need to use Pythagorean theorem. So I'm going to do 12 squared plus L squared equals 20 squared. That gives me 144 plus L squared equals 400. Subtract that 144 over, and we get 256. Take the square root of that, and we get 16. So that means my other side is 16. Now I can go to my formula. Area equals length, which is 16 times 12. And when I multiply those together, I get 192. Add my units as inches squared. So you can see it might not be as straightforward as just length times width. We had to use Pythagorean theorem there. Let's try this. We have a square. Find the area of a square with a diagonal of 6 root 2. So I'm going to draw my square, all my right little angles, and my diagonal measures 6 root 2. Well, I know in a square that all the sides are the same, so I'm just going to call them x, and I have to do the Pythagorean theorem. So I'm going to do x squared plus x squared equals the entire thing 6 root 2 squared. X squared plus x squared is 2x squareds. This square is going to square the 6 and the square root. So I'm going to have 36 times 2, which is 72. I want to get to the x. Right now it's being squared and multiplied by 2, so I'm going to divide both sides by 2. So I get x squared to be 36. I undo the square by taking a square root, and I get x to be 6. So all of my sides are 6. And if you remember, when we did special right triangles, a square is going to be divided up into a special right triangle. So these are little 45, 45, 90 triangles. So that should make sense that I have a side that's 6, 6, and my hypotenuse is 6 root 2. So if you can recognize that, you would not have to use the Pythagorean theorem. So I see that both my sides are 6. My area is 6 squared, and area equals 36 centimeters squared. Here we have a parallelogram. The top is 10, my angle 75, just this little piece is 3, therefore I know that that would be 7, and I need to figure out my height. So I have my perpendicular height, And I'm just going to draw this triangle out to the side. So we have a little triangle with a 75-degree angle and then a 3. And I need to figure out my height. So in this case, we have to rely on right triangle trig. I'm going to go to my 75. I have my opposite and my adjacent, which means I'm going to be using tangent. So tan of 75 equals h over 3. I'm going to multiply both sides by 3. So h equals 3 tangent of 75. And when I do that on my calculator, I get h to be 11.2. Now I'm ready to put that into my formula. So the area equals my base, which is 10. And just because it's on the top, that doesn't mean it's not a base. It's still a base. So my base is 10. My height is 11.2. And when I multiply that, I'm going to get 112. There's no units there. You could put u squared for unit squared if you like. Let's look at the area of a triangle. So find the area of an isosceles triangle with a base angle of 40 degrees and a base of 8 inches. Lots of vocabulary. Isosceles, base angle, base. So I'm going to start with my isosceles triangle. That means we have two congruent sides. The base angle is 40. These are the base angle. And because it's an isosceles, we can use the base angle theorem to say that they're both going to be 40. And a base of 8, this is my base. Those are my legs. I need to find my height. So I'm going to take out a half of that triangle. That means my bottom is 4, my angle is 40, and I need my height. There's my little right angle. So I'm using right triangle trig again. I go to my 40. I have opposite and adjacent. So it's another tangent. So we're going to do tan of 40 equals h over 4. Multiply both sides by 4. And I get h to be 4 tangent of 40. Do that on my calculator and I get about 3.4 as my height. My base is 8 and I do need to use the whole base, not just the 4. So area equals 1/2. My base is 8. My height is 3.4. Now be careful with the 1/2. It's not distributive. It doesn't go to both of them. It just goes to one of them and it can go to either one. I'm going to multiply it by 8 because it's even. So now area equals 4 times 3.4. And when you do that on the calculator, you're going to get 13.6 inches squared. Area of a trapezoid. We've already gone over this, and we also did median. So this trapezoid has a median of 18 inches and a height of 12 inches. So let's see what we have. Here's my height. Oops, equals 12 inches. My median is 18 inches. Well, I don't know my base 1 and base 2 over here, base 1, base 2, because it's not labeled. But I do know my median. And if you remember, median equals 1/2 the bases added together. Well, I have that right there. So it's essentially that formula multiplied by h. So I'm just going to rearrange it. Equals 1/2 my bases added together times the height. My bases added together times 1/2 is my median. So we could say this is the median times the height. So I have my median, which is 18, times my height, which is 12, and I get an area of 216 inches squared. In our last shape, let's look at the circle. We haven't done much with it yet this year, so I'm going to draw my circle. I'm told it has a diameter of 12, so I'm going to go right through my middle. Diameter equals 12. Well, the formula calls for radius, so you have to make sure you cut that in half. The radius is only going to be 6. Area equals pi 6 squared. Notice I put the word exact in capital letters. If something is exact, it keeps the pi, because pi goes on forever. I don't want to round it. So using pi is exact. So this exact answer is going to be 36 pi centimeters squared. If you're curious what it looks like as a decimal, you could multiply it out on your calculator and you're going to get about 113.1 centimeters squared. So if it doesn't say exact, you can go to the calculator. If it says exact, you're going to stay with the pi. So those are your area formulas, and we'll be practicing them in next class. Good job.